All right, so we're going to continue this section 6.1. And then you should be able to finish those, what was it, 14 to 18? Is that what you said? Okay. So you should be able to get those finished after what we do today. So, yeah, sorry about not saying anything yesterday. But we just didn't get that far. So let's talk about this. All right. Just seeing where I wanted to start here. I'm going to draw a quadrilateral. It's not going to be any kind of a special type of quadrilateral, just any old quadrilateral, which means what? If it's quadrilateral, what's really the only thing I know about it? I got four sides, okay? So let's just draw it like this. Well, let's draw it. Let's just get rid of that. Let's draw it like, what do I want to do here? I just want to make it look like the sides are not parallel to each other because that's another story. It doesn't really matter. They could be parallel to each other for this to work. It doesn't make any difference. So what I'm going to do is introduce a word. I don't believe... Have we talked about diagonals in here? Okay, I didn't think we did. So let's talk about what a diagonal is. Let's write that word down, okay, because we're going to be using that quite a bit in this little section. Okay, let's talk about what a diagonal is. A diagonal is if you take any vertex. Now this happens to be a four-sided figure. That's where we're going to start. But then we're going to expand out to a 5-side, 6, 7, 8, 9, 10, whatever. Doesn't matter what number, sided polygon, okay? We're just going to start with a four-sided polygon right now, which is a quadrilateral. Then we're going to expand out a little bit more than that, all right? So what I'm going to do is take any vertex. It doesn't matter which vertex. You know what a vertex is, right? It's where the sides come together to a point, any vertex. What I'm going to do is draw a line from this vertex to another vertex, but not just to any old vertex, to a non-consecutive vertex. What does that mean, non-consecutive? First of all, what does consecutive mean? It means the one right next to it, right? So from this vertex to this one right here, that would be a consecutive vertex, wouldn't it? Because it's right next to it. There's another consecutive vertex right here. Those aren't diagonals. So if I drew a line, see that red line right there? If I went from here to here, that would not be a diagonal. From here to here would not be a diagonal. Where would the diagonal be in this situation? From this vertex where? Right, across to the opposite side. Okay, that's a good way to say it. Okay, across to the opposite side. So that would be a diagonal. All right? Everybody with me on that? So you start at any vertex. I didn't have to start right here at this particular one. I could have started here, here, or here. It doesn't make any difference. But I could still only draw one diagonal in this situation. All right? Is that the only diagonal I can draw? Yeah, because if I start from from this vertex, I should say that. Because I could draw another diagonal from here to here, couldn't I? All right, so yeah, technically there is two diagonals. And we are going to do that a little bit later on, a 3 lessons from now. But right now, I just want to start at one vertex. So draw a diagonal from one vertex. Everybody got it? All right, and again, it doesn't matter which one. So what have we made now? We started off with a four-sided figure. We've kind of divided this, haven't we? We divided it into two what kind of polygons? Two triangles. That's right. So this would be one triangle. Would you agree? And this would be a second triangle right here. All right? What we're going to do, the title of the lesson says it. We're going to find the angle sum, the sum of the angles. First of all, what does it mean to find the sum of something? Add up. That's right. We're going to add up. And what are we going to add up? Add up all the what? The angles, okay? You already know the angle sum of one polygon. What is that polygon? A polygon. 90 degrees is not a polygon. A polygon. Nope. It's a triangle. That's a polygon, okay? Whoops. I'll tell you what. Let's just do this. Do it right. Okay. So let's just go back. We've talked a little bit about triangles, haven't we, so far this year? We talked quite a bit about triangles, to tell you the truth. And we have talked about this. This is definitely something we've talked about. We've already talked about an angle sum. Have a seat. Have a seat. So we already have talked about an angle sum. We've talked about it as far as a triangle is concerned. So what is the sum of the, I'm going to say the interior angles of a triangle? What do all the angles add up to be? 180 degrees. 180 degrees. Everybody with me? Okay. So now what I want to do, I want to find the sum. I want to find the sum of the angles of this quadrilateral. And you might already know that. When you walk through the door, if I would have greeted you at the door and said, what's the angle sum? What are all the angles of a four-sided figure add up to be? What do you think you would tell me? Anybody know off the top of their head? 360 degrees. That's probably something that you've learned in the past, right? You probably don't know why it is, all right? And actually, when we talked about the angle sum of a triangle, we actually talked about why is it 180. I'm not going to discuss that right now, but just know that it's 180. So what I want to do is I want to figure out what are all four of these angles. I'm just going to put one tick mark. It doesn't, or one little arc to them. It doesn't mean they're equal to each other, okay? I'm just showing where the angles are, all right? So what I'm trying to do is I want to find the sum of all four of those angles. All right, that's the goal. That's what we're trying to do, all right? And you already said it's 360, right? But why is it 360? Well, I'm glad you asked. Take a look at this. You've got this triangle right here, don't you? So what do all the angles of that angle one, or that first triangle add up to be? 180 degrees. So the angles there add up to 180 degrees. What about this second? I'm not going to shade it in, but what do all three of the angles of the second triangle add up to be? They add up to be 180 degrees. So if I combine this triangle and this triangle, what do all the angles add up to be? That's it. So 2 times what? 180, which is 360. And it's degrees. I should put a little degree symbol there. Okay. Everybody see that? So that's why they add up to 360. All right. So what you do is this. You're not going to see it right now, but in the next couple, you're going to see like a little pattern developing. And I want you to see the pattern. Okay. I could just sit here and just tell you what our little equation is, what our little formula is, and just say, okay, here's a formula. This is how you use it. Go ahead and do the homework. All right. I could do that, but that wouldn't be so fun, would it? I want to set a pattern. I want us to come up with the formula together. All right. So this is the first step. So if you have, let's write this down. If you have 4 sides, I'll tell you what, let's write this down underneath this. If you have 4 sides, and I draw a diagonal from one vertex to all the non-consecutive vertices, how many triangles am I going to have if I have 4 sides and I draw that diagonal? I got 2 triangles. Agreed? And then each triangle is 180 degrees, so how do I find the sum of all the angles of the 4-sided figure? 2 times what? 180, and that's equals what? 360 degrees, okay? Now what I'm going to do is I'm going to do the same thing, but I'm not going to do it with a 4-sided figure. What do you think the next thing I'm going to do?
5.
Go to 5 sides. So let me just turn that into white. And again, it doesn't have to be like a perfect, by the way, what do we call a 5-sided figure?
Pentagon.
Not a gram, a gon, pentagon. Okay, so 1, again, I'm not going to try to make this look like anything special. There's 2, there's 3, there's 4, and there's 5. Okay? So it's 5 sides. It's not a special polygon. It's not a special pentagon. It's just 5 sides. Okay? So what are we going to do? To find out how many triangles we have, we're going to start at a vertex. It doesn't matter what vertex. Okay? We kind of started over here the last time. It doesn't matter. Let's start right here. All right? It does not matter. I could start anywhere. I want to draw a diagonal which goes from one vertex to a non-consecutive vertex. So from there to there. Would you agree? Is that the only diagonal I can draw from that one particular vertex? No, I could draw another one, couldn't I? All right, I could draw it from here to here. Could I draw any other diagonals from this one particular point? Okay, I got to start right here.
I think so.
No, because the only other vertex I could go is to here, and that would be right on top of it. That's not non-consecutive, is it? Shh, stop. And then from here to here, that would be consecutive, not non-consecutive. So that's all the triangles that I could draw. Or all the diagonals, sorry, I'm getting ahead of myself. Akira, you with me? It's too early to start nodding off yet now. We're getting to the good stuff. Okay, let's take a look. Let's watch. So how many triangles do I have here? I got 1, I got 2, I got 3. So let's go over here. So how many sides? 5 sides. Gives me how many triangles? 3 triangles. And what's that? 3 times what? 180. Why 180? Because I got 3 triangles, right? Each triangle is 180 degrees. I got 3 of them. And then so 3 times 180, I should know that. What is it? 540?
So
Okay.
sides, can we just know that it's 4 triangles or no?
Well, we can, but let's take a look at it first, okay? But that's a good point. Tell you what, I'm going to use this little thing, this polygon tool. If I click on here, when everybody's finished taking the test. All right, so there is a, and again, this does not have to be a regular pentagon, or in this case, it's 6 sides. So what's 6 sides? What do we call a 6-sided figure?
Hexagon?
A hexagon. That's right. If I could grab this thing.
Hecagon is like 9.
Hecagon? No, there's no hecagon.
Shut up, don't talk to me.
All right. Let's stay color coordinated here. Let's make that white, and then we'll make our diagonals red. All right. So now let's start from any vertex. It doesn't matter what vertex. Okay, we picked one over here. We picked one over here. Let's pick one right here. It doesn't make any difference. So let's draw all the non-consecutive diagonals, or the diagonals to the non-consecutive vertices, I should say. So bottom right. I'm already at the bottom right. So I can draw one to here. Agreed? I can draw, again, starting from that same vertex. Whatever vertex you pick, always start from that vertex. I could go to here. I could go to here.
And that's it.
And that is it. Right. I can't go to here because that's right next to it. Can't go here because that's right next to it. So now, Timmy already saw the pattern just with 2 things here, but seeing the third thing kind of establishes a pattern. How many triangles do I have? 1, 2, 3, 4. So if I have 6 sides, I'm going to have how many triangles? 4 triangles. Now, at this point, you probably see a pattern developing, don't you? This is 4 times 180, and that is, what, 720? Okay. Do you see the pattern? So what if, let's kind of work our way down. What if you had 10 sides?
Is it always 2 less?
It's always 2 less. That's right. Okay, look at it. I mean, it just goes by 1, right? 2, 3, 4. The next one would be 5, 6, 7, right? Until you get to 10, it would be what? 8. But what did we do? We had 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. What did we do to each of those? We took 2 away, didn't we? So how many triangles am I going to have with 10 sides? I'm going to have 8 triangles. I mean, I could draw that picture out, but that would be just a waste of time, wouldn't it? All right, you see the pattern developing. So now, what is the angle sum of a 10-sided figure? So that would be what? 8 times 180 degrees. And I have no idea what that is. Is it 1440? That sounds about right. So 1440. Okay? So that's how many degrees all the angles add up to be. Does that mean each angle is 1,440 degrees? No, it means all 10 of them add up to 40 degrees, or 1440 degrees. Does that make sense? It's the angle what? What's the word? The angle. It's the title of the lesson. Sum is the angle sum theorem, okay? So it's the angle sum. It's the sum of all the angles, which means if I add up all the angles to that particular polygon, they're all going to add up to 1440. And again, it doesn't matter how it's shaped. It could be shaped all crazy, all right? As long as, by the way, I failed to mention this. These all have to be convex polygons, okay? They can't like cave in, right? That would be a concave. Remember that? Remember I had a test on that stuff? So they all have to be convex polygons. So I should have said that at the very beginning. I probably won't say convex every single time. We just understand that it will be convex, all right? And that's how you do that. So what if I did this? Now this is going to be really weird, but this is something you do in algebra a lot. Let's change colors. A lot of red going on there. What if you had n, that's supposed to be an n, lowercase n. There we go, it looks a little better. An n number of sides. How many triangles are you going to have? N minus 2, very good. Because what did we do with that? We took the sides, and what did we do to see how many triangles we had? We took 2 away every single time, didn't we? We took 2 away from 4, 3 away from 5, 4 away from 6, 8 away from 10. So what? 2 away from n, because n just represents any number. It could represent a 12. It could represent a 72. It could represent 1,000, a million, okay? So how do we find out how many triangles do we have if I have that many sides? I take 2 away from it. So I've got n minus 2 triangles, which means what's the sum of the angles of any sided polygon? N represents any sides of a convex polygon, all right? So what's the formula? It's n minus 2 what? Times?
180.
180. 180. All right, look. We went 2 times 180, 3 times 180, 4 times 180, 8 times 180. So we're going to go what? N minus 2 times 180. That right there is your formula to find the sum of the angles of any convex polygon. It was a lot of words, a lot of geometry words, all right? If that was the first day of school, you probably wouldn't have understood almost everything I just said right there, but now you should understand it. So what are we finding? This is the formula for the sum of the angles of a what? Convex polygon with n number of sides, all right? So what if I gave you, so there's our little formula. What if I said that you had a polygon with, I don't know, let's do something weird, 17 sides. All right, so you had a figure, it's a convex polygon, all right, and it's got 17 sides. And for some reason, you needed to find the sum of the angles of that polygon that has 17 sides. You should be able to do it. Anybody got a calculator out with them? Bring the calculator out really quick. Somebody have it? I got one right here. Who can Here you go, Ethan. Punch some numbers in, all right?
What numbers?
Well, you tell me.
17 minus 2.
That's it, 17 minus 2. Very good. So it's 17 minus 2,
15.
and then times what? 180. So basically, you're just going 15 times 180. Somebody get the door, please. What is it? 2700? And that would be what? Degrees, right? What does that mean? What does that 2700 mean? Exactly right. You said it perfectly. It's what all the angles add up to be. All right? It's what all the angles add up to be. So if I had something that had 17 sides, watch, I can actually do this with this little program right here. Hit Polygon Tool, click, oops. I got to just hit it once. There we go. And I could put 17. You want to see a 17-sided figure? It doesn't even have a name. It's so weird. All right, so 17-sided figure. Oh, that's really, here, I can do this. There we go. There's 17 sides right there. Everybody see that? All right, if you count them up, there's 17. All right, so what does that mean? What's the 2700? That means it's that angle plus this one plus this one. I'm not going to do that all those times. But if you added up every single one of those angles, guess what you're going to get? 2,700 degrees, 2,700 degrees. All right? Everybody with me? I think I saw when we were looking at the homework, I think it said, what is the angle sum of a septagon? Let's do that together. What's a septagon? Do you remember that? 7. 7 sides, okay? So a septagon has 7 sides. So the question says, what's the angle sum of a septagon? So what do? What's the math?
5 times 180.
Right. Well, let's put it down. Let's write it down. 7 minus what? 2 times 180. Who's got the calculator? Punch it in. What's 5 times 180? 900? Okay. So that's 900 degrees. There you go. I just answered one of the problems on the homework for you, okay? It is easy, isn't it? You just have to know what the formula is, okay? You got to know this. Let's go a step further. What if I told you that it was a regular polygon? What does that mean to be a regular polygon? We have discussed this. It was a while back, but we have discussed this. 2 things must be true about it. All the sides, if it's regular, all the sides are what? The same. They're equal. Okay, let's not say the same though, okay? Because each side is different, agreed? Each side is different, but they have the same length. All right, the same length. Doesn't mean they're the same side. I know it's picky, but you got to be picky sometimes. So all the sides are equal. What else could possibly be true about a regular polygon? I put two things. What else? Say it. Who said it? Angles. Okay, all the angles are what? Are equal to each other. Okay, so a regular polygon means all the sides are equal and all the angles are equal. Everybody got that? You remember talking about that earlier in the year? We didn't harp on it, but I think we might have mentioned it once or twice. Okay, and we didn't go crazy on it. So this little thing that I'm using right here, this polygon tool, let's not go 17. Let's go something easier. Let's go 8. We haven't talked about 8 yet, so let's do that. All right, so there's an 8-sided polygon. Now, this program that I'm using makes it into a regular polygon. It automatically does that. So I don't have to like make sure the angles are equal and the sides are equal. It automatically makes that. So what's true about all these sides? They're all what? Equal to each other. What's true about all the angles? They're equal to each other, okay? What I want to do is I don't want to just find the sum of the angles. That's easy enough, right? So what would we do to find the sum of the angles if it's 8 sides? We would go what? 8 minus 2 times 180. So somebody give me that number. So that's 6 times 180. I should know this, but I don't know. 1080? Yeah, I recognize the numbers, but sometimes I just can't think of them. So that would be 1080, correct? But that's the sum of all the angles. That's what all these angles add up to be. But here's the question. Now, this only works when it's a regular polygon. If it's some funky looking polygon, right, all the sides are different lengths and the angles are all different, this won't work, okay? But if it's regular, if it's a regular polygon, what do you think I want to find now? That's right. I want to find what though? What am I trying to find? Just one of the angles. That's right. Each angle. Let's say each, okay? So I want to find each of the angles. Just one of them. All right? Or I could find all 8, right? Because if I find one, what's true? They're all equal to each other. Exactly right. So I just want to find one angle, all right? And Tristan, you came up with it already. So what are we going to do to find each angle?
Divide by 8.
That's it. So it's 1080. That's what all the angles add up to be. Now, we don't divide by 6. Remember we went 6 times 180? Because there's not 6 sides. How many sides are there? Or how many angles are there? Right. There's just as many angles as there are sides, okay? So there's 8 angles. So I take the 1080 divided by 8, and I believe that's what, 135? Who's calculator guy? 1080 divided by 8. I think it's 135. I should know this. Yep, I was right. So it's 135. What is that?
That's an announcement on some sports dismissals. Girls varsity basketball, you have a dismissal time up to 2:15. Middle school boys basketball, you have a dismissal time of 1:30. You'll be departing upper school lobby at 1:45.
That's Kate and them?
Boys varsity basketball.
That's 2016.
You don't have the early dismissal. Your game is at 7 o'clock.
Stop yelling out.
All the early dismissals. Thank you.
Stop yelling out, I said. So what did we just find? We found what? Each of the angles. So every single one of these angles, you're going to leave in a second. You keep doing this. I asked you not to talk, and you keep blurting things out. How more clear can I be? I kicked 2 kids out of my last class. I'll do it again today. You're doing it again. You just have no filter, do you?
That was not me. What? That was not me. I did not say that.
You think it helps your cause? It's not helping your cause. Just zip it. So each of these angles is 135 degrees, all right? So you got to read carefully on these problems because you may look at it and you're like, oh, it's one of those ones where I just go n minus 2 times 180. And you might say, oh, my answer is 1,080. But the question says what? Find each angle. Is that correct? That is not correct, all right? So each angle, each angle would be what? 135. All right, so this would be 135, so would this one, so would this one, so would this one. All right, and if I added them all up, all those 135s, I add them up 8 times, and what am I going to get? I'm going to get 1,080. So the sum of all the angles, so the sum of the angles is equal to 1,080 degrees. Do you see the difference? All right, so you take the sum, you multiply, or you divide it by how many angles that you have, which is the same number of sides that you have, right? Because they might not tell you this polygon has 8 angles. They'll tell you the polygon has what? 8 sides. Or they might just tell you that it's a what? A regular, if it's 8 sides, what is it? It's a regular what? No, if it's 8 sides, if it's specifically 8 sides, what's it called? It's an octagon, thank you. It's an octagon. So they could tell you, you've got a regular octagon, find the sum of the angles of a regular octagon, right, they could ask you both of them. They could say, what is each angle of a regular octagon equal? Okay? So that's the kind of stuff that they're going to ask you. We got a couple more things to look at real quick. It kind of has something to do with what we just did. It's a little bit different, though. So this is kind of interesting. I think it is, anyway. So let's just draw. I'm just going to draw a quadrilateral right now. And then I'm actually going to draw a triangle. Actually go smaller instead of bigger. But I could draw any of these. Let's just draw from here to here and here to there. Okay. Now, what I'm going to do is this. Thank you. I'm going to take each of these sides. And what I'm going to do is I'm going to extend one. How would I say this? I'm going to extend just in one direction, one of these sides. So I'm going to take that side and extend that side this way. Okay, I'm not going to extend that one out. I'll just take this top one, extend it that way. I'm going to take this one on the right, and I'm going to extend it like this. I'm going to take this bottom one, I'm going to extend it like this. So what am I forming now? I'm forming some other angles, aren't I? And what are they? Are they interior or exterior angles? They're exterior angles, aren't they? All right, so that's what I'm going to talk about here in a second. We've talked about exterior angles. Remember we did alternate interior angles and then alternate what? Exterior angles? Yeah. So we've got some angles in here. What's really cool about this, we don't even have to come up with a formula. Okay, they just tell you that this is true. So I'm going to put some numbers in here. And these numbers will all add up to, I'm going to give you the interior angles. What should all the interior angles add up to be? It's 4 sides, 360. So if that's 73 degrees, now this is approximate, all right? It might not be exactly 115, but they will add up to 360. And then 67, all right? So those should add up to 360. You can check my math if you want. I believe they do, though. So what I want to do, though, is this. Let's find each exterior angle with this information. So how would I find this angle right there? What would I have to do to find that angle? It's something we've done before. It's just not new. Okay, Caleb. It's what? What was the first one? 180. Okay, I didn't hear that. Yep, it'd be 180 minus what? 115. Because it forms what? It forms a straight line. How many degrees is a straight line? 180 degrees, right? So this is whatever's left over from 180. Would you agree? And what is that? 65? Yeah. So this angle is 65. I'm just for the sake of time, I'm going to go a lot faster, okay? This one would be 75 degrees. This one would be 113 degrees. How am I finding all these? I'm taking them away from what? From 180, right? And this would be 107 degrees. Oh, you gave my calculator back. It's kind of fun when you put it into your calculator, but that's okay. I'll just tell you what it is. If I add it up, 107, 65, 75, and 113, the sum, I'll write it like this. The sum of the exterior, the red ones are the exterior, okay? The exterior angles is going to equal 360 degrees. Now, the question is, does it add up to 360 degrees because the interior is 360 degrees? It doesn't, because if I tried it again with another one, now I could go to a 5-sided figure, but I did a triangle. Let me show you this. And I could keep doing this, until I got tired of it. But I'm just going to do it one more time. Now check this out. I'm going to take each, let's extend that like that. Let's extend this one like this. So I just take each of the sides and just extend it in one direction, okay? Not both directions, just one direction. So I got me some exterior angles. So what did I make the interior? Yellow on the last one. So if this is 46 degrees, this is 25 degrees, and that's 109 degrees. What should they all add up to be? All the yellow ones. It's in a triangle, 180, okay? Should be 180 degrees. Everybody with me? So what I want to do is I want to figure out my, what? Exterior angles, all right? And again, I'll just write it down. But how did I find that exterior angle? How did I get that to be 134? Yeah, it took 180 minus 46, okay? And that's that. This one would be what? 71 degrees. And this would be 155 degrees. Now, if I add it up, what is the sum of the exterior angles to this one? You'd think it'd be 180, right? The other one, the interior was 360, the exterior was 360. The interior, this is 180. You would think the exterior might be 180, but it's not. Okay, it's way more than that. It's what? It's actually 360 degrees. In fact, it does not matter how many sides you have. This is the cool part about this, okay? I think this is cool to me. The cool part about this is it doesn't matter how many sides that you have, okay? I could take a 10-sided figure, extend each of the sides, right? And then figure out what all the angles are. And you could see that the exterior angles will always add up to be, that's the sum. Timmy, I'm up here, not up there. The sum of all those angles is going to be 360 degrees. Every single one. So what if I had a pentagon, a 5-sided figure? What's the sum of the exterior angles of a pentagon? What is it? 360. What's the sum of a 17-sided polygon? What's the sum of the exterior angles? It's 360, okay? It does not matter how big the polygon is, okay? And it doesn't even have to be a regular polygon, all right? It could be any kind of polygon, a regular convex or any convex polygon, okay? We're all saying convex here. So that's our theorem. Our theorem is in this box right here, that the sum of the exterior angles of any convex polygon is always 360 degrees. Now, the interior angles change, don't they? I had 4 sides. What was the interior angles to that? 360. What was the interior angles to this one? 180. Okay, so the interior angles change depending on how many sides you have. But does it matter how many sides you have to have the exterior angles, or to figure out the sum of the exterior angles are? No, it doesn't matter. It doesn't make any difference. It's always going to be 360 degrees. All right? And there is a kind of a cool thing. It's not going to show, well, maybe I could get it to show up. Do I have enough time? I only got like 3 minutes. Let me see if I can do this as quick as possible. And I'm going to have to change this. Oops, change this to right there to that. Get rid of, yeah, there we go. All right, so I got that up on there. Oh, and that's not what I wanted. I didn't want Desmos. I wanted the GeoGebra. Oh, I think I'm running out of time. I don't know. Let's click. Let's see if I can do this. I don't know if I can. Let's get rid of that. Let's bring up GeoGebra. It'll take a second for it to pop up. But this is kind of cool if I can get it to work. I got 2 or 3 minutes. I gave you a lesson plan yesterday, so you know what the homework is, so I don't have to write that down. Okay, what I'm going to do is draw a polygon, I think. No, that's not what I wanted to do. Hold on. I'm just flying by the seat of my pants here. Let's there should be a thing, because I didn't do this for my other class, but I thought, oh yeah, here we go. I'll just do regular polygon. All right, regular polygon. Let's see, how do you do the regular polygon? I guess I'm not going to do it. I should have been more prepared, but there's 4 vertices. Let's do like 100 vertices. Let's see this. Now watch. So it's getting, there's 100 sides to this, 100 angles. All right. Oops, that's not what I wanted. Let's cancel that. Hold on. Don't leave yet. Don't leave yet. Look at this. That's 100 sides right there. If I zoomed up, you would see, right, just a slight different. It's not an exact circle. Okay, it's actually a whole bunch of different sides. If you zoom up to it, I'd have to zoom up a whole lot. Yeah, that's all I can zoom up. All right, so you can't really tell that they're straight sides. But it did. It said regular polygon, right? And I put 100 sides. What's it starting to look like? Or what does it look like already? It definitely looks like a circle, doesn't it? What do you know about the degrees of a circle? It's 360 degrees, isn't it? Okay, so that's kind of interesting, right? So the more and more sides that I have, okay, the more it starts looking like a circle. And what are all the exterior angles add up to be? No matter, even if you have 100 sides, what do all the exterior angles add up to be? 360, right? So if you had 1,000,000, that would look even closer to a circle, wouldn't it? All right. If you had 1,000,000,000, it would even be closer to a circle, right? So that's kind of interesting to see that you could take a shape, a polygon with straight sides, and if you have enough sides, it looks really, really, really close to a circle, which is how many degrees? 360 degrees. I think that's kind of interesting. You may not, but I think it's kind of cool to see that there's definitely a relationship between those. All right, everybody good? All right, so I asked you to do 1 through 18, so there's a few that you should be able to do. So you're going to finish up with 19 to 34. Let's keep it A and B. So I'll give you, 5 points for one, 5 points for the other. That rewards you if you did both of them. Now, if you don't do both of them, that does not reward you. I'm going to collect it tomorrow, I said. Okay, so we're going to do A and B. It's 6-1A, 6-1B, and that will be due tomorrow.